All right, you got lucky today. 2 videos. Substitution. All right, remember there's a solve and check for this. So substitution, I'm going to use this guy. I'm going to change that equation. So let me work it out here. The first thing I'm going to do is change that equation. So it's in the format of y equals mx. Well, I want to isolate. Let me rephrase that. I want to isolate one of the variables. In this case, I'm going to isolate y because it's halfway done for me. So 5x plus y equals negative 13. Y is already by itself, so all I got to do is subtract negative 5x from both sides. And I get y equals negative 5x minus 13. And that's what I'm going to use. So that's going to change to y equals negative 5x minus 13. So I'm going to use substitution. So this is equation 1, this is equation 2. So in equation 1, I'm going to substitute. So wherever I see y, I'm going to replace with negative 5x minus 13. So I get 6x plus 6 times negative 5x minus 13 equals negative 6. Order of not operation. We got to do distributive property. 6x minus 30x minus, what is that, 1878 equals negative 6. Combine like terms, yeah, these two. I get negative 24x minus 78 equals negative 6. We're going to do plus 78, plus 78. That goes away. Negative 24x equals positive 72. Divide by negative 24, divide by negative 24, and x equals, nice and easy, negative 3. Right? So I found the x value. So remember, we need a coordinate, right? So our answer is going to be in this format. Because it's 2 lines, right? When we do graphing, it's 2 lines that intersect, and the point of intersection is the solution to both the equations. So x equals minus 3. So now I want you to go back to your original equation. So you can pick, doesn't matter, equation 1 or equation 2. Let's pick equation 2 because I think it's easier. Equation 2, and equation 2 is negative 5x plus y equals negative 13. So I'm going to replace this x here with the value just found, which is negative 3. So I get negative 5 times negative 3 plus y equals negative 13. That's going to be positive because the negative times the negative. Positive 15 plus y equals negative 13. We're going to do minus 15 and minus 15 to isolate y. So this goes away, and y equals plus 15, right? No, minus 15. Negative 28. Sorry, yeah, negative 28. So our solution is negative 3, comma, negative 28. And we have one more step. Let me get some room here. I gotta do a check. So I'm gonna have to check in equation 1. So I've got 2 checks. Make sure that point works for both equations. I do something wrong here. That's positive 15. Oh, sorry, I did do something wrong. Nobody said anything. I know, so I should have written this more clearly. So it's positive 2. So my solution, sorry, it's negative 3, comma 2. Right? I just got to read my own handwriting. All right, so let's try it out. So in equation 1, my pen works, 6 times negative 3 plus 6 times 2 equals negative 6. 6 times negative 3 is negative 18. 6 times 2 is 12. And you'll see that it works for equation 1. So equation 1 is a check. Equation 2, 5x plus y equals negative 13. 5 times negative 3 plus 2 equals negative 13. 5 times negative 3 is negative 15. And if you add positive 2 to that, you guess what? You get negative 13. So notice that this point here, our solution, works for equation 1 and equation 2. Yeah, there's a lot of work. So that's substitution. Elimination, which, I don't know, thinking order. Elimination would be my second choice. Graphing is everyone's first choice. Elimination. So we either need to get rid of the x's or get rid of the y's. It doesn't matter who, right? So we either add equation 1 with equation 2, right? Or we subtract. It's really up to you. But notice that, so you either pick x's or y's. All right, who do you want to eliminate? I'm going to choose the x. So I'm going to multiply. Remember, I want to have the same coefficient, right? So I'm going to multiply equation 1 times 3. And I'm going to multiply equation 2 times 5. I mean everybody times 5, right? And then on the first one, everybody times 3. So let's see what we get. So on the first one, we get 3 times 5x, we get 15x. 3 times 4y, which is plus 12y. And then 3 times negative 14, which equals negative 42. Bottom line, bottom equation, 5 times 3x is 15x. 5 times 6y is positive 30y. And then 5 times 6 is 30. Now, what am I going to do? I'm going to subtract equation 1 minus equation 2. So be careful here. 15 minus positive 15 is 0, so that's going to go away. 12y minus 30y is going to be negative 18y. Negative 40 minus 30 is going to be negative 72. Divide both sides by negative 18, and y is equal to 4, positive 4. All right, so now that I found y, I'm going to go back to my original equations, erase that, and either you pick equation 1 or 2, and you plug in y. So let's pick equation 1. 5x plus 4y equals negative 14. 5x plus 4 times 4, because that's the value of y, equals negative 14. 5x plus 16 equals negative 14. We're going to subtract 16 from both sides. We get 5x equals negative 30. Divide both sides by 5. And we get that x equals negative 6. So here's my solution. The point negative 6, 4. It's the point of intersection for both lines. Now we got to do the check. So, in our check, I'm going to take both equations. Let's try equation 1. So it's equation 1. So here, remember, this is x and this is y. So I'm going to replace x and y with the respective points. So it's 5 times negative 6 plus 4 times 4 equals negative 14. Let's see if that's true. 5 and negative 6 is negative 30. 4 and 4 is 16. Look at that. It is true. Equation 2. 3 times negative 6 plus 6 times 4, that should give us 6. 3 times negative 6 is negative 18. 6 times 4 is 24. And guess what? It does work. So the point negative 6 and 4 truly is the solution to both equations. Okay, and that's elimination. Now we do what? Oh, graphing. Yay. So let's do graphing. So made it easy because they're both in the y-intercept form, so we don't have to change anything. They're ready to go. So let's graph equation 1. Let me just write it separately here. Y equals negative 2x minus 4. And I'm going to put that 2 over 1. And the second one is y equals 4x plus 2. And I'm going to put the 4 over 1. Right? Notice that the first one, it's a negative slope, so the line should be like this. And the second one is a positive slope, so the line should be going up. All right, so let's start graphing. Let's do the first one in red. Negative 2 over 1, so if you want here, that's a change in y, and this is a change in x. All right, so left and right, you're going to go 1 unit. Up and down, you go 2. Where's y-intercept? The y-intercept is negative 4, right here. 1, 2, 3, 4. That's my y-intercept. So from here, up and down, I'm going to go 2 units, and then left, I'm going to go 1. There. Up and down 2, left 1, 2, 1, and there. We have more than enough points to graph a line. So let me connect the dots. And that should be red, red, red. Try again. Okay, so I'm going to just put it right there. Yeah. And if anything, we should have stretched that. There. Much better. And give this guy a name. Y equals negative 2x minus 4. Intercept of negative 4 and the slope of negative 2. The second one, I'll put it in blue, it's a positive slope. 4x, again, I'm going to put this on top here. So up and down, we're going to count 4, left and right, changing x value is going to be 1. And then y-intercept is positive 2. So here's my y-intercept right here. So we have a line that's going to cross the y-axis through 2. So 1, 2, 3, 4, and we're going to go 2 to the right. 1, 2, 3, 4, and 2 to the right. No, sorry. 4 and 1 to the right. 1, 2, 3, 4, and 1 to the right. And then if I go down here, 1, 2, 3, 4, and I'm going to put a circle because right there, notice that 1, 2, 3, 4. That point right there is the one point that these two lines share. They're right, their point of intersection. So I'll adjust the line in a second. There we go. And this line is called y equals 4x plus 2. I'll change to a green color right there. So this is the solution to our equation. And it looks like it's -1, comma, -2. Right, and we're going to do a check. So let me erase some of this stuff away. Just write it again. So y equals -2x minus 4. So again, let me write the solution, -1, comma, -2. It's my x and my y. Let's see if it works. So I'm going to replace. Y is -2. -2 times -1 minus 4. -2. 2 times -1 is +2. And +2 minus 4 is indeed -2. So equation 1, check. Equation 2. Y equals 4x plus 2. Let's replace y and x. So y is -2. 4 times x, which is -1, plus 2. -2 equals 4 times -1 is -4. And we're going to add 2 to that. And guess what? It equals to -2. So this is our point of intersection. Truly is the solution to our equation, our system of equations. We have one more, I think. Yeah, we do. So this one is inequality. So I like inequalities. Yeah. But you have to be neat. That's the thing here. Right, neatness counts a lot. All right, let's do the first one. The first one, it's a positive slope, and I'm going to put it in blue. Positive slope, it's already 1/2, and our y-intercept is 2. So +2. So up and down we count 1, left and right we go 2. So up 1, 2 to the right, up 1, 2 to the right, up 1, 2 to the right. There. Enough points for me to draw this line. Okay, so this one is the one we have to shade. So it's going to be a solid line because of this guy here, right? So the points on the line are included in our solution. So now we want to just make sure, so is it this area above the line, or is it this area below the line that makes that first inequality true? So either all the points above the line or all the points below the line make that inequality true, the first inequality. So let me clear this. We take a test point, try 0, 0. Let's try 0, 0, right? We're going to test 0, 0 in the first inequality. So y less or equal to 1/2 of x plus 2. If we try 0, 0 and we plug it in, we get this. 0, 1/2 times 0 is 0, and we just get 2. So 1/2 is less or equal to 2. It is true, right? Isn't 0 less than 2? Yes. So we don't want the points above it because they're not going to make my inequality true, but the points under it. These points right here, every single point, including points on the line, you can pick, will make the first inequality true. Okay, so you don't have to go crazy, but you gotta be neat, and I think that's important. All right, equation inequality 2. Y is less than -2x minus 3, and I'll put that over 1. Let's graph that. So it's a slope that goes down, and the y-intercept is -3. So the y-intercept is here, 1, 2, 3, right here. It's going to go down. It's up and down we count 2, and left and right we count 1. So 2 and 1 right. 2 and 1 right. 1, 2 and 1 left. 1, 2 and 1 left. Right, we have enough points. And this one is going to be red. Let's stretch that out. Right. So now points on the line do not make that inequality true. So I had to use a dashed line, which I am going to do now. Sorry. Here's my dashed line. Right, because points on the line do not make this inequality true. We use a dashed line. So again, let's do a test point. Let's try 0, 0, because I'm either going to shade above this line, to the right of that line, or below that line, right, to represent the area that makes that inequality true. So if you try 0, 0, you get 0 less than negative 2x over 1 times 0 minus 3. 0 is less than negative 3. Well, this is not a true statement. So 0, 0, which is right here to the right of the red line, did not work. So if that did not work, it means that anything to the right of the red line will also not work. So we're interested in the other side. And that's where I'm going to shade. You will notice that there is an area here where the blue and the red meet, and that's our solution area, because that tells us that points in here, where I made the big S, pick any point in this area, will make both inequalities true. Right, now the trick here, not trick, but make our life easier, is to pick a point that is easy. Well, I'm going to pick this point right here. I'll put it in, I don't know, purple. I want the easiest possible point. I'll pick that point. That point is negative 3, 0. So I'm going to try negative 3, 0. Anything with a 0 is always easier. So let's try inequality 1. We're going to go 0 less than 0 less than 1 over 2 times negative 3 plus 2. 0 less than, that's negative 1.5 plus 2. 0 is less or equal to, and that is 0.5. Is 0 less or equal to 0.5? Yes. Let's try inequality 2. And I use the same point, negative 3, 0. So I'm going to use this inequality. So 0 less than negative 2 times negative 3, right? Because this is my x and my y values, minus 3. 0 less, negative 2 times negative 3 is negative 6. Minus 3 is going to take me to negative 9. No, actually, sorry. Negative 2 and negative 3, 6 positive, minus 3. And 0 is less than 3. Is that a true statement? Yes, it is. So notice that this point here worked, right? And that point is in the solution area. So if you have time and you have nothing better to do, hey, pick this point, plug it in, pick this point, plug it in, pick this point, any point in the solution area, and plug it in for y and x in inequality 1 and inequality 2. It will work for both. Okay? So again, lots of solving and lots of checking here. Okay? Yeah, that's about it.